Okay, so to really talk about chemical equilibrium, we're going to need, or at least acid-base equilibrium, we're going to need a couple of different values to let us really do this job well. So first off, let's talk about something in organic chemistry that you'll see a lot of, which is functional groups. So functional groups are just a way of trying to describe the shape of a molecule. So there are some motifs for molecules that are going to be represented over and over and over again. And so they're so well known that we actually give them names. And so pKa, we've already talked about pKa, that's just how acidic a molecule is. And we're also going to give names for each one of these molecules. Okay, so functional groups, this guy's name is going to be a carboxylic acid. This H3O plus, sometimes you'll see this H3O plus designated as hydronium. And so a couple more in H3 plus, and this molecule, its functional group name is called an ammonium. This is an alcohol, and then another functional group that we'll need to know, this functional group's name is amine. So if you look at the amine versus the ammonium, they're very similar. So the only difference really is that the ammonium has a positive charge and the amine has a neutral charge. And it turns out that whether the nitrogen has this positive or neutral charge, this is going to change how acidic that nitrogen is. And we'll see that with the pKa. So if you actually look at the pKa's for these molecules, you'll find that the hydronium has a pKa of -2, and then next up we have carboxylic acid. This guy's pKa is 4.7, and the next ammonium, its pKa is 10, and then the alcohol's pKa is 15, and then finally the amine, its pKa, again, is not going to be 10 because this guy is neutral, this guy is positive. So it turns out that whenever you go from a positively charged nitrogen to a neutral nitrogen, the pKa goes up, which means that the acidity goes down. So the amines are much less acidic than the ammoniums. So these have a charge of about 40.